All right, welcome to Unit 10. Unit 10 talks about two concepts, exponents and with roots, particularly square roots. So let's start off with exponents. When I look at, when I write the same number over and over and over again, we call that repeated multiplication. And often, instead of writing a number multiple times, such as we did here, where I have 7 times 7 times 7 times 7 times 7, we use an abbreviated notation called exponential notation. And since 7 is being multiplied by itself 5 times, we would write that as 7 to the power of 5, um, which means the same thing as 7 times 7 times 7 times 7 times 7. Now in this case, we call 7 the base, and 5 is called the exponent, or sometimes we call it the power, but we usually call it the exponent. So a couple things that we want you to be able to do. If I have repeated multiplication, such as we do in example number 1, we want you to take that and rewrite it in exponential form. So in this case, it's 9 that's being multiplied by itself. So 9 becomes the base. And we just have to count up how many times it's being multiplied by itself. So in this case, 1, 2, 3, 4, 5, 6, 7 times. So we'd write that as 9 to the 7th power, which means exactly the same thing as we've written out in expanded form. So in this case, the other thing that we're going to ask you to do is identify the base and then evaluate. Now evaluate means find out what is this equal to. So 4 to the power of 3, sometimes we call that 4 cubed. So 4 is the base, and what this means is 4 times 4 times 4. Now 4 times 4 is 16 times another 4. Now if we have to do that longhand, we can do that. 4 times 16. 4 times 6 is 24, so I'm carrying 2, so that's 64. So we'd say 4 cubed is equal to 64. If we look at b, 7 squared, or 7 to the power of 2, and again we call it 7 squared. 7 is the base, and what this means is not 7 times 2. That's not what this means. If I wanted 7 times 2, I would write it differently. This really means 7 times 7, and 7 times 7 is, of course, 49. So those are a couple of things that we want you to be able to do with exponents. Write it in what we call exponential form. Expanded form is when we write it the long way without the exponent, and then evaluate means find out what that number answer is. Now the next thing we want to talk about is perfect squares, okay, and the connection to square roots. If I look at this square right up top here, what you'll notice is that it's 2 units wide by 2 units high. So if we were to multiply that out, 2 times 2 is equal to 4. So this one would have an area of 4 square units. Okay. If I look at this one's 3 units by 3 units, so its area is 9 units squared, or 9 square units. And if we continue on, 4 by 4, well, if I multiply that out, its area is 16 square units. And lastly, if I look at this one isn't a square. Now, why isn't it a square? Well, if you look, it's 5 units by 4 units. We wouldn't consider this to be a square. So if I multiply that out, I get 20. 20 isn't a perfect square. A perfect square basically is formed when I take a number and I multiply it by itself. So an example of perfect squares would be numbers such as 1 times 1, which is 1, 2 times 2, which is 4, and we showed you that is an area. 3 times 3 is 9. 4 times 4 is 16. Now if I take 5, 5 times 5 would give me 25. That would be a perfect square. 6 times 6 is 36, and so on. Those are what we call perfect squares. Now why are they called squares? Well,
Mr. Cuff, please phone the office. Mr. Cuff, phone the office, please.
My apologies. If you look at the area, if I take something that's 16 square units, I can make a perfect square out of it. If I take something that's 20 units like this, I can't make a perfect square out of it using whole number values. So in terms of the area, these things are perfect squares. One that's 4 square units, 9 square units, 16 square units, and so on. Now, what's the connection between a root and an exponent? Well, what I'm asking here when I ask for this is an inverse operation, and this is called the square root of 49. And what this is asking is what number multiplied by itself gives me 49. In other words, what times itself gives me 49? Or another way of putting this is what squared is equal to 49. Now, the most common mistake that I see students making is they think of taking that number and dividing it by 2. But we're not adding, we're thinking back here. So if I was to talk about the square root of 16, another way to think about it is if I have something that's 16 square units long, what's the side length if it's a perfect square? And the side length would be 4, because 4 times 4 is 16. So the question is, what squared gives me 49? Well, 7 squared gives me 49, since 7 times 7 is equal to 49. So we'd say the square root of 49 is 7. Okay? Now, often, one like example number 4 bothers students because they see 17 squared is and I want the square root of that. Well, remember, this is saying what squared gives me 17 squared? Well, the answer, of course, is 17 because these are inverse operations. They undo each other. Just like adding and subtracting undo each other. Now, let me give you an example. If I was to take the number 19 and add 6 to it, right, and then subtract 6 from that, well, I don't even have to do the intermediate calculations. If I add 6 and subtract 6, I'm going to end up where I started with. Now, I'll prove that to you. When we add here, that gives me 15, so I'm carrying 1, that gives me 25. Now I need to borrow, so I reverse this. 15 minus 6 is 9, 1. These are inverse operations. They undo each other. Squaring a number and then taking its square root does exactly the same thing. So I want you to be comfortable with the idea of writing a number as an exponent, evaluating that exponent, and then the idea that if I take the square root of something, I'm asking what number squared gives me that result.